This is the Turf Zone Podcast, your central information and news hub, bringing together professionals from turf associations across multiple states to share things to help you in your business. Brought to you in partnership with our friends at the Pennsylvania Turfgrass Council. Now, let's get in the zone.
Welcome to the Turf Zone. In this episode, we feature an article titled State of Matters, Irrigation, written by Max Schlossberg, Ph.D. The important cultural practice of irrigation comprises three components. They are, in chronological order, monitoring, control, and delivery. They may ring familiar, too, as they were just articulated by Dr. Grady Miller in the September 2021 issue of SportsField Management on page 50. Imitation is the sincerest form of flattery, right? Then I added some otherwise original content and withheld discussion of the control component for last. Monitoring. Current monitoring tools and techniques have undergone significant advancement in recent period. While they share the common goal of providing timely soil water status to managing personnel, they fall into one of two categories: using climate data to estimate soil water. Environmental monitoring affords professional turfgrass managers incredibly valuable information. Predictive models use real-time climate data to guide scheduling of cultural practices, supporting accuracy and adopter appreciation. New irrigation systems and controllers often include environmental monitoring instruments that automatically compile the data for input into prediction models, run them, and adjust irrigation controller runtimes accordingly. These are commonly referred to as evapotranspiration (ET) controllers, and may be available as retrofits for older systems. If this technology is interesting news to you, then please start a conversation with your neighborhood irrigation vendor or technical rep. Otherwise, many regions of the U.S. are covered by statewide or local ET monitoring networks. This may not relay real-time environmental conditions specific to your location, precipitation, humidity, etc., but likely will provide useful hourly or daily summaries of potential ET across your region. Nonetheless, it is important to realize ET models estimate only extraction of water from the root zone, not an explicit or certain irrigation requirement. Irrigation need arises when soil water storage required to support turf health between now and the next irrigation opportunity falls below a critical level. Accurate soil water storage estimates rely heavily on site-specific edaphic properties, the effective turfgrass root depth, the mean plant available water holding capacity throughout the effective root depth, and the estimated soil water storage at monitoring initiation. Predictive models, not updated by site-specific determinations, often employ default settings on varying suitability. Update these settings with representative soil laboratory test results to optimize turfgrass performance and irrigation efficiency. Using sensors and meters to measure soil water. Direct real-time measurement of soil water comprises a significant added value to environmental monitoring. Soil moisture data is collected automatically by installed and static sensors or manually using portable meters. Below-ground sensors may be monitored remotely by smartphone networked to your irrigation system controller or both. Having discussed such technology with Mr. Derek Prune, lead agronomist for UGMO Technologies and two-time PSU Turfgrass advisee and alum, I learned wireless undergrass monitoring technology currently directs the automated irrigation of over 1,000 facilities in North America alone. Portable soil moisture sensors and meters employ 1 to 6-inch long time domain reflectometry (TDR) rods or capacitance probes to measure soil water content rapidly and accurately with minimal disturbance. I emphasize soil moisture sensors and meters to prevent readers from making handheld pocket-sized moisture meters, from measuring firewood or drywall wetness as appropriate for turfgrass applications. They are not. Portable soil moisture meters are 2 to 3 feet long and quite pricey, but promptly support general diagnostic inquiries all across your facility. Where irrigation water costs are high, portable soil moisture meters promptly pay for themselves. Yet, Overwatering is so agronomically counterproductive to turfgrass that I'd argue these portable soil moisture meters pay for themselves where water is free. Many late model meters are GPS compatible and complement GIS platforms with meaningful map layers. But dependable collection of meaningful data requires compliance with manufacturers' recommendations during both setup and subsequent usage. The performance of portable soil moisture meters is governed by proper rod and probe length selection and optimized by initial and subsequent calibrations. Furthermore, the steel rods and probes of moisture meters will wear down with repeated use and sample shallower depths over time. Operators should interpret the resulting data accordingly and replace rods and probes as needed. If you have already adopted these monitoring tools and technologies at your facility, kudos. The overwhelming response I hear from managers and superintendents who have adopted irrigation monitoring instruments and soil moisture meters is this. Without them, they would have never realized how much they previously overwatered. Delivery. Optimized replenishment of soil water storage beneath our coveted turfgrass is the final, yet undoubtedly most critical stage of the process. Imagine a facility with brand new pumps, a fertigation tank, an ultra-modern central controller, a wireless network of multiple environmental monitoring instruments, buried soil moisture meters, and single rows of heads with missing or worn nozzles on terminal laterals branching out in every direction. It's as sad as a shiny Carver amp playing the White Album through speakers detached from a 1994 Panasonic stack. So don't mistake my tone as unenthusiastic about irrigation. Modern irrigation systems are amazing technological advances that support efficient water use and conservation. But if a new install isn't in the cards, optimizing water delivery can pay dividends. The number of valuable recommendations for optimized delivery of irrigation is too great to reproduce in full. If you seek comprehensive refreshing, please consult irrigation BMPs available throughout numerous trade associations or university extension or outreach websites. But a few worthwhile suggestions include irrigating during still conditions, in pulses when delivering a sizable soil water recharge, and uniformly over the target area. Rate and uniformity of water delivery by an irrigation system are determined by an irrigation audit. Numerous descriptive university extension and outreach publications are available in support of this procedure. A guide by the North Carolina State University Extension Service succinctly describes the required materials, detailed steps, and summary calculations. A well-executed irrigation audit reveals necessary repairs and adjustments as well as information needed to adjust runtimes and nozzles on a zone-by-zone basis. Data collected by Texas A&M's AgriLife Extension show water savings from irrigation audits averaged between 12 and 30%, equating to 700 million gallons annually in Texas alone. While a proper audit will likely prove worthwhile, a beneficial outcome will depend on committed effort and patience. I recommend the family pack of dedicated collection cans that feature wire stands and etched graduations because you simply can't have too many. The graduations facilitate trouble-free data collection and accurate irrigation rate determination. The gradations facilitate trouble-free data collection and accurate irrigation rate determination. Some website instructions offer cost-cutting alternatives, like a sleeve of stackable solo-type cups for collection by a one-time audit. They further suggest users expedite the data collection process by measuring depth of irrigation captured in each with a ruler and recording the irrigation depth as head units. This will suffice for auditors seeking to determine only distribution uniformity. Because stackable cups taper wide to narrow from top to bottom, this approach will inflate irrigation rate measurements per unit runtime. Control. In all candidness, it takes extraordinary confidence in his or her team's assessment of current conditions for a manager to withhold irrigation another night in July. It may additionally require a greater than 40% chance of afternoon thunderstorms tomorrow, or perhaps a greater than 60% chance of afternoon thunderstorms tomorrow. Regardless, deciding the current soil water storage that will adequately support turfgrass health until the next irrigation opportunity arises is how turfgrass managers conserve water. For any given year, if we knew the number of times professional managers applied irrigation within 24 hours of a sizable rainfall event unnecessarily, then we could compare it to the number of times significant turfgrass areas perished due to reckless withholding of irrigation. Am I implying one number consistently exceeds the other? No. The data hasn't been collected, and I never imply. Rather, the message turfgrass science sends us is that good information, a talented supporting staff, and a confident mindset can make both numbers 0. Overwatering is irresponsible, injurious, and arguably the foremost scourge on our industry. I mean, come on, 14-year-old TikTok influencers get 8,000 likes for dogging neighbors irrigating in the rain. In addition to broader societal benefits associated with not wasting valuable resources, irrigating unnecessarily can stress and injure turfgrass. This is especially true of intensively managed cool season turfgrass during extended periods of high temperature. The overarching paradox is clear. A clientele that made beaucoup investment in supporting infrastructure won't forever tolerate a superintendent appearing to underutilize it. As a result, risk aversion makes unnecessary irrigation a more common outcome than drought stress injury. But a reasonable counterpoint is my favorite Dr. Clint Waltz Jr. adage. Just because you currently have formula and a bottle warmer doesn't mean it's time to feed the sleeping baby. If you are already employing modern instruments to actively monitor ET and soil water storage, and the irrigation delivery in every zone of your facility has been audited in duplicate and features a near 100 distribution uniformity, and you follow all the recommended BMPs, but you still rarely encounter drought stress and wonder if you aren't somehow overwatering, then I recommend one last procedure to support your water conservation goals. Take the one-off challenge to calibrate your water use know-how. For the proud DIY professionals, an inexpensive yet meaningful and intuitive way to judge your soil water assessment skill is to just turn off one of your sprinkler heads. I'm serious. Spring is a really good time to take the one-off challenge. Pick a head that services a fairly typical soil profile at your facility and manually key it to off. Avoid predominantly annual or rough bluegrass stands, opting instead for a system populated by species capable of recovering from short-term drought stress. An ideal spot is at the beginning of a frequently visited fairway and near your maintenance facility. Now, you may be wondering why anyone would do this. It certainly isn't predictive or proactive like estimating or measuring soil water. It won't afford any utility until irrigation is applied. But for turfgrass professionals who strive for improvement, it may prove a valuable retrospective self-evaluation tool that recalibrates your irrigation decision-making. For example, the longer the sprinkler head stays off without reduced vigor or density of the service turfgrass, the more productive the exercise will prove. As a professional, you'll be prepared to turn the head back on when required. This time will arrive under all but the rarest of summer weather conditions. For those managing facilities where dry seasons prevail, the one-off challenge may be terminated after the first week. But if this helps a manager identify a recent irrigation event was unnecessary, then it was an informative week. Return the sprinkler head to operation if the serviced areas present symptoms of drought stress, wilt, discoloration, matting, footprinting, or the current climatic conditions compel initiation of a leaching requirement. For all resources associated with this article, check out our show notes. Don't miss an episode. Subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. You can also visit us at theturfzone.com.
You've been listening to The Turf Zone. For more episodes of The Turf Zone, visit theturfzone.com and subscribe on Apple Podcast, Stitcher, or your favorite podcast app.